Hello friends, welcome back to our channel. So today we'll see one more concept in our machine learning, that is proximity measures. So here the word the proximity means the similarity. So in machine learning, the basic part we have to know is the proximity measures. So this proximity means answering two questions. So whether the two objects are similar, two objects are similar, and or two objects far apart. So here the word proximity means comparing two objects and giving the similarity. So this we call it as a similarity measure, and this we call it as a dissimilarity. So we know the complete introduction about the machine learning. So we have studied in our earlier sessions that machine learning will be used to classify the objects or clustering the objects. And also it will be used to recommend the products in online platforms. So for all that cases, the backend used is this proximity measures. So it will compare two objects. Now, example, let us take an example. Let us consider two students. So one is a student A, another one is a student B. So if you are comparing the marks for these two students, student A and student B. So if student A got 95 percentage and student B got 94 percentage. So here you can see both are almost similar, very close. So we can say both are similar. So both are studying well in the same manner. Now, if you go with the student C, the third student C. So student C got some 60 percentage. So you can clearly observe there is a lot of difference between these two things. So student A and student C. Similarly, student B and student C. So you can see these and this one are not similar. So from this output, I mean the result, we can say student A and student B are the fast learners and student C is a slow learner when compared to the student A and student B. So here we are comparing and we are deciding. So this kind of process we call it as a proximity measures. Now, hope you understood what exactly mean the proximity measures. So now the types of proximities. Types of proximity measures. So there are two types. One is a similarity measure. Similarity measure. And the second one is dissimilarity measure. Dissimilarity measure, or we can also call it as a distance measure. Okay. So for both the types of this one, the numerical value will be calculated. So these proximity measures are mathematical methods. Mathematical methods. So why we are using these mathematical methods means in order to determine the similarity between the objects. So we'll be using some mathematical methods, right? So here the similarity measure and the dissimilarity measure. So in this similarity measure, there will be only one value, numerical value will be given. So numerical value, it can be represented with a numerical value, and this value will be ranging in between 1 and 0. Similarly, here also it will be represented with a numerical value, and this numerical value will also be in between a range 0 and 1. Okay. So don't get confused between this one range. So it is 1 and 0 and 0 and 1. I am writing just with a small change. So here range between 1 and 0 means 1 specifies, if the range is 1, specifies objects are similar. Objects are similar. Okay, equal. And if it is 0, it implies the objects are different. Objects are different. In our previous example, we have seen some 95 and 94, so almost similar to 1. Okay, so that means both are similar. And coming to the student C, which is who is having some 60%, so there is a slight difference. So the difference between those objects is more, so it will be different. And here the quite opposite. 0 represents similar, and 1 represents, that means more value, represents objects far apart. That means the distance is more. That means the dissimilarity is more. The best example for this dissimilarity measure is distance from home to college. See, for example, if the college is beside your home, the distance is very small. That implies similar. Okay, if the college is far away from home, that implies it is a far apart. Okay, so that's a simple example to understand what is a dissimilarity measure here. So here, in order to find out this numerical value, or in order to measure this similarity measure, the examples for this one are cosine similarity, okay, and for this one, examples are Euclidean distance, a numerical, Manhattan distance, etc. So these are the measures, I mean these are the methods or techniques we will be using to calculate the dissimilarity measure, and here the cosine similarity will be used for measuring this similarity measures. So hope you understood the difference among the similarity measure and dissimilarity measure. And now, what are the applications? So where these proximity measures will be used? So all the applications of machine learning, the proximity measures will be used. So let me explain. So applications. So the first one, in k nearest neighbor algorithm, KNN algorithm. So why we will be using this KNN algorithm? So this is a classification algorithm. So in the classification algorithms, we will be using this proximity measures. Similarly, k-means algorithm. So where we are going to use this k-means algorithm. So what exactly mean this k-means and KNN algorithm, we'll see in our further sections. Okay. So this is for clustering. So classification means you can simply use labeled data, and clustering means unlabeled data. So just a grouping. Okay. Next. Recommendations. Recommending products. Recommending products. So for example, you can take any online platform. So if you are searching for a particular mobile in that platform, like Amazon or Flipkart, etc. So the similar kind of products will be recommended multiple times. So that will happen because of this particular proximity measure. So recommending products, which is used in online platforms. And also to document comparison. So comparing multiple documents, that we call it as usually text mining. It is called as a text mining. Next, feature similarities. So where we are going to use these feature similarities. So image processing. Image processing. In the image processing also, in order to identify the images, we'll be using this proximity measures. And finally, detecting anomalies. That means the objects which are far away. That is called as an anomalies, right? So which we can call it as a unusual data or abnormal data. Unusual data or abnormal data. So in all these cases, we'll be using these proximity measures, right? So these particular proximity measures are the mathematical methods, and that helps the machine, to find similarities. See here, I'm just giving the overview. So classification, object classifications, clustering, okay, finding neighbors, nearest neighbors, anomalies, recommendations. Right? So this is the complete applications where we are going to use these proximity measures. Mainly two proximity measures. One is a similarity, another one is a dissimilarity. Right? So hope you understood this one. This is a very basic concept in our machine learning. Everyone have to know about this before applying the machine learning algorithms. Okay, the concept behind the algorithm, you can say. Right? So I'll stop here, and if you are having any doubts regarding these proximity measures, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed this session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.